Hey Ronnie, welcome back.
Hey, great to be here. Thanks for having me.
Yeah, we had already conversation about milk, and you said, Americans love milk, and this
hmm
was news to me. So okay, I didn't knew about that.
Oh, yeah. I guess in the 80s and 90s, there were a lot of milk commercials that were extremely, I think, successful as commercials go.
Okay,
Like they managed to get it into people's head that if you drink milk, you'll be taller, you'll be more healthy. Now, of course, milk is okay. I'm not saying that it doesn't have calcium and things like that, but they managed to also kind of create the right PR for it.
this is how Marvels happened, right? All the heroes they were just a run on milk, basically.
Definitely.
Perfect. So I forgot when it was the last time. I think last year for sure. It
hmm
was summer. You
hmm
know it.
I think so. I think so.
Mhm.
It was just about a year ago.
So, and what happened in the time? So, you told us last time
hmm
that you prefer the Java community,
hmm
and because you get nice community and you got lots of feedback. Is it
hmm
still the case, or to say, okay, no, I don't like them anymore. I will do, I don't know, JavaScript instead, or what?
No, if anything, I think it's more so the case.
Hmm.
All of the kind of early intuitions I had about the community back then came true and more. So it's awesome to be speaking to people on an almost daily basis from the community and getting great ideas. Really, it's like if you can crowdsource ideas, like that's the best way to go about it, because there's so many people that are so smart out there that are thinking about different practices. So just learning from them has been a great journey for me
Hmm.
personally.
And product wise, did
hmm
something happen with from
Yeah.
what's the name of your product again?
It's Digma.
Digma. Hmm.
Yeah. So when we met last time, we were this kind of niche boutique beta early access thing where we had maybe less than a dozen of users that were all friends of the community, kind of people we met along the way that saw the potential and kind of wanted to see it through. And today we have like hundreds of users joining weekly, so that's really great. It's a much bigger than I anticipated. Of course, with users also come a lot of kind of ideas, opinions, bugs. So we've been very, very busy because of that, but it's good busy. I really like it. And for me personally, it also is amazing to kind of see something that you're crafted being in use and getting feedback about, where you did things wrong, where you did things right. It's really crucial to understand. It's also like I guess in my background, I previously worked on these very boring enterprisey, well, not boring, some of them were cool, but enterprisey applications where the feedback that you got was like, yeah, you go out to the customer, you go over an Excel sheet, and basically it's kind of like a quarterly update. And having real life feedback when somebody can just reach out on Slack and say, hey, this is not working, or sometimes, and I really appreciate that about the community because I don't do it enough. People just reach out and say, hey, this is really awesome, thanks for making it. This is making my day.
Hmm. Okay. So, the elevator pitch. What is Digma? To remember, because I think you have. Yeah.
Yeah, so the elevator pitch is really simple. Observability is something many organizations have, many users have it. Some of us have it without knowing because, our libraries support open telemetry. So basically all of the data is there if we activated it. But the truth remains that we're not using it almost at all in dev and test. And we do use it in production, but only reactively. So after the fact, after a problem
Hmm.
already manifested in production, then the alarm bells go off. And what we thought to ourselves is, hey, what's the reason that we're not using it on a daily basis? And the reason is two things. First of all, that it's not continuous. So just like testing, you don't just run the test because you feel like it. It's supposed to be a part of the process. So A, it needs to be continuous, and B, it requires a lot of mental effort. Even if you have the latest, APMs, you need to go over graphs and dashboards and understand kind of where it's your fault, where it's not your fault, what's related to the code, what might be in the DevOps world. And so we said, let's create something that will use data science, all of the latest things that we can do with data, to just check that for you. So imagine you just have an experienced developer always looking at the logs and traces, always searching for anomalies and stuff that you should notice that are related to your changes. And basically not coming back with a lot of raw data to kind of start analyzing it yourself, but come to you with the conclusion, hey, I found this issue in your code. Go look at it. And the difference is that unlike static analysis tools that mostly go after styling and different aspects of the code complexity, this goes after runtime data. So what we've found out was that just by analyzing, even in your local dev environment, and most certainly as you run your test and as you move on to kind of staging environments, and definitely from production, you can just capture so much information, so much useful information about your code that can help both in the use case of validating it early, catching issues early, preventing them from entering your PRs and from propagating all the way as escape defects, but also being able to design code better. Because if I want to start writing code and I understand the limitations and requirements, and I understand the other microservices that are using the specific query that I'm just modifying, or that I understand exactly where the bottlenecks are in this specific area of the code that I should watch for, if I understand the concurrency model, all of these are things that can save us a lot of time and avoid a lot of mistakes. So looking both at design and validation, I think this is really kind of a different way to code, so to speak.
So what I would expect to have some assertions in unit tests, right? Which are synced with the current state of the open telemetry metrics, right?
The way we go about it is we ingest data, a lot of it, and working on the data stream, we start running different kind of data science checks. Some of it uses machine learning, some of it uses just plain statistics and regressions and things like that. And the idea is that, first of all, we don't send anything to the cloud. Everything can run local on your machine. And it's basically just a plugin you install into your IntelliJ, which is the platform that we support right now. And basically, as it runs behind the scenes and analyzes your code, it just comes back with code insights, as we call them. So another strategic decision we made is not to be service-centric, but to be code-centric, so that I know how this function behaves, so that I know how this query behaves, I know how this endpoint that I wrote behaves, and what are the different issues there. So when we come back into when we enter the field of vision of the developer as, hey, look, something is interesting here. A, it's because it's something that should warrant your attention, and B, it is only then that you can go to the raw traces, logs, and metrics and so on to find out like the history of it, or to go a little deeper. So kind of inverting the pyramid, where usually you would just go dig into a lot of data and then maybe try to find something interesting. Here we just start with the interesting part, and then if you want to see the related history and more raw data, that's where you can do it.
But what I could do, I could use this data for assertions in system tests, for instance. This is what because how it works in my projects is I have actually in Java two projects. One is the service, and the other project, within Quarkus, it injects the stubs. This is the microprofile REST client, and it calls the service. So what I could do is I can use your data for my asserts and see, okay, I call the method, it is executed on different JVM, but I would like to know if there's some regression or know what happened behind the scenes.
Definitely, and this is exactly what we're exploring, and we started releasing features for lately, which is when observability meets testing. And this is maybe the larger topic that I felt my head was filling with a lot of thoughts about it. I thought might be great to share here, which is how can we use observability effectively in testing, or how can we get more out of testing using observability. And I actually had some thinking about this and also wrote a blog post that I'll share with some ideas. And the basic premise was, is the testing pyramid that we all grew accustomed to and kind of were educated by still valid? The testing pyramid where it's like most of it is unit test and some of it is integration test and some of it is end-to-end. And after kind of looking into it, I thought, yeah, as you said, that it's no longer a valid pyramid. So what does the new testing pyramid look like? And what I tried to look at was so the two axes that I think it was the Martin Fowler pyramid had were slowness, I think, and then the other one was I don't even remember what was the other axis, but it was also not very relevant to me. And what I was trying to do is create another pair of axes where it's more about the cost in terms of complexity, in terms of slowness, in terms of other things, and then the value, and then see where we can kind of position tests. And it seemed that in both of these dimensionalities, there was a big change in the last years. So in terms of complexity, if you're using test containers, then there isn't the complexity that existed before. And I kind of lived through that when I wrote some testing frameworks at the time. And when I did, setting up the test environment was such a hassle. It was so brittle. It added flakiness. It was slow. But today, if you're using containers or test containers or anything that's very today very integrated into the frameworks, you remove a lot of that complexity. So if you look at an integration test, sometimes the cost of actually adding a test using test containers that works on real services versus the cost of completely changing your design just to allow unit tests to be effective is not what it used to be. And I would often just prefer using test containers. And from the other side, or does that align, by the way, with your view on the testing world?
There's a RHXFM podcast episode number 103, and with Alexei Golub, unit testing considered harmful, and this was 4 years ago. 4 years ago,
I love
and
it.
This was exactly the also my opinion. And what I do in my projects is, for me, first, unit tests in a microservice are defact if they are coming first. Because in all my client assignments, when something went wrong, was usually the following situation: everything is green and doesn't work, right? And the bigger the project, the worse it gets. Because
the notorious false sense of confidence.
Yeah. And I think the problem, or not the problem, is I thought when the project, when the projects are good projects, and I think when the developers feel responsible for the success of the project. And if you feel responsible for the success of the projects, you are less interested in metrics and more about the project, right? And if you have a microservice, which is a remote service, it is clear that the integration points, the I/O with the database and the transactions and concurrency are the problem, not necessarily, unit testing the business logic, because these errors are easier to solve. And therefore, in my projects, I expect this is like end-to-end test first, and my system test is I call it system test. And what it is I would like to have the automated access to the entire API with system tests.
Mm-hmm.
So we write the system test first, so something gets called, and we see. I would like to see in the logs that the server was actually called, right? So this is
Mm-hmm.
the what interests me.
Mm-hmm.
And if we need authentication, then let's do authentication. It is hard, but we need a solution anyway. So we do the authentication and whatever. So there are no excuses. And unit tests, I only write unit tests to skip some iterations. Because without unit tests, I will have to full deployment, and run the system test. But sometimes it's quicker to write unit tests. So I write unit tests, which for more complex logic, or a classic is string manipulations. It is just easier using unit tests. But unit tests don't matter. And it don't matter at all. And actually, in my current projects, I always, ask the developers, what's about system tests? And I don't care about they writing unit tests or not. Because the end to S is the truth, right? The unit test is a helpful utility. Of course, there are cases where you have insurance company, whatever, where there's lots of calculations. Then it flips. Then the core domain logic is more complicated and requires more testing than the outside API, right? External API.
Yeah, for sure. I agree with that, and also I think that it's kind of taken a while, but I think we're growing out of that habit of, like, as an industry, of writing a lot of unit tests first, whether you needed them or not. I'm not even talking about the practices that we used to have, that you have a method, you need to have a test method by the same name. You have a class, you need to have a test class by the same name. It was
this is really bad. I think strategy, and the quality of the code is incredible. So what I saw, everything is mock out, and what really happens in larger projects, they are actually testing the mocks.
Yeah, or they copy the same logic twice, which I also
saw. So and if you change a line in the production code, you have to change the unit test. This is like, this is like almost like, how to call it? You are line by line, the unit test is almost the production code with some, verifications. It doesn't test, the actual logic. It tests whether the method was called and the method is there. It is like, I wouldn't trust JVM. This is what it looks like, I saw tests where they call it getter and then ask in test, the getter was called once. So of course, I mean, man, if this doesn't work, we are not testing JVM here, right? So we should be, and so what I do is that there was a cyclomatic complexity in SonarQube. And in my project, it was forbidden to write tests if the cyclomatic complexity was lower than 3, let's say. So if else. And so getters and setters was absolutely not allowed. But what happens in projects, this is where developers wanted to start with, because you can achieve higher code coverage, If you test the trivial stuff first, there are lots of trivial stuff there. So you have already maybe 40% code coverage without any effort. Crazy stuff. I saw, reflection frameworks, which called everything to increase the code coverage. Yeah.
So I think,
but it happens less and less, I would say. Now,
I think so, and I think we're in agreement about like that.
Yeah.
But then I think so. What I tried to do was to think about the problem. Okay, so on the one hand, there is the matter of cost. So cost of tests, especially integration tests, is much lower. I'm not even talking about the fact that you don't need to design for testability and all of these things that just introduce a lot of abstraction sometimes that you don't need to have. But then on the other hand, what can you gain from tests, or what is the value that you can gain from tests? And this is where I was feeling a lot of excitement, because the very basic value that you can get from tests is assertions, is basically simple functional assertions that are great. Please write them. But the fact is that often they also can lead to a false sense of confidence, because you're sometimes coding the test to your biases. So you describe a behavior, you test it, which is great because you don't want to have a regression. But you're out of all of the possible things that, now that you have your kind of perfect setup for this scientific experiment where you're running different components and microservices even, you're only checking this one thing, but my intuition was that you can get a lot more out of it, meaning that as you write these integration tests, they just create a lot of extremely useful data. Why is it extremely useful, and even more so than production data sometimes? Because it's kind of like the perfect experiment where nothing changes almost except for the code itself. So you've essentially locked down the other variables, and now you've changed the code. And now you can start looking at the changes, not just in terms of the assertions that are pretty static and, again, narrow in scope, but in terms of the system behavior. So kind of using the test as a platform to test more things, like, maybe I've mistakenly added 40 queries because I called some abstractions and it was running some database query was behind the scene and I didn't notice it. Maybe I've introduced a performance regression. Maybe I've created an anti-pattern, like an N+1 select, or like an open session in view, or something else that I didn't notice. So all of these things are not easily picked up by tasks. They're definitely not easily picked up in code reviews because they're often missed. But they are there in the data. So, something that I hear a lot is the phrase like the writing was on the observability wall, because, in lots of situations, we get to a problem and then say, oh, of course, now that we look at the logs, we see that this service was calling the other service that it shouldn't, and so on. So using that data as a platform is a great idea in my mind. And that's why we started also connecting those test runs and the observability to Digma as well. So and this is extremely interesting even to see for the first time. So imagine you have any asset. It doesn't even have to be a code asset. It can be a code, a consumer. It can be a database query or an HTTP call. And then you look at that, and from the inside out, you can say, okay, so which tests are actually triggering this query, which is an interesting thing to check. And then looking at those tests, you can start looking at changes over time, which is where it gets interesting. So, and you can start noticing when things changed and whether it's something that is anomalous enough that you should be able to detect it. So what we're seeing as we're using this internally is that it makes us be able to use tests to a much greater degree, and especially integration tests versus unit tests that produce very little useful observability data.
Yeah, I have two ideas for the cloud. One is simple and the other one is maybe harder. But what I already did actually is the following. So you mentioned the costs. And the question is why, for instance, most of my project right now are serverless. And why serverless? For different reasons, but one main driver are costs. But serverless doesn't have to be cheaper. It is cheaper for enterprise projects, but if you are under heavy load in one point of time, bare metal becomes cheaper than serverless or containers. And so what interests me is, we have some use cases, and the use cases can be triggered by system tests. Now, if we invoke the system tests, how expensive is it really, the system tests? And so how to do this? Simple but cumbersome. What I did, I counted the invocations, let's say, to S3 API. Then I knew, the length of the call. Then I knew the lambda duration, and I could calculate the total costs for the system tests, the true cost, dollars, And what I did, I think the first time, I had a logger which actually printed the dollars, to the log, to get a rough estimation. Are we still on track? Is it still cheap or not? And Digma actually could have dollar assertions, because you could absolutely do this. I have some end-to-end tests and a system test order something, and if the order it calls one lambda, then there's an API gateway lambda S3. But I mean, the Java code which calls S3, we know the Java code. You only have to measure this performance. You don't have to to process the AWS SDK. It is enough, to have the Java code there, and just a simple and cost calculator would be of. So this is the first one. The other one is a little bit harder, and so this was like the synchronous Lambda, but they are asynchronous processes which are way harder to test. Yeah. And what I thinking about right now is to implement a state machine, like a watchdog, which tests an asynchronous process. And so let's say you have Excel upload, to S3 bucket, then an event happens and Lambda wakes up, picks the Excel, processes the Excel, and you would like to have, let's say, a PDF with the summary in another bucket, right? So how to test that? And so how you could test that is that you can listen to events and see whether an event happened. And this is a little bit harder, but if you could gather, the information for both Lambdas, it is a little bit simpler. And by the way, they also
possible because at least the convention is for PubSub and distributed tracing to pass on the trace ID
exactly
when it's possible. So
yeah, this is X-ray or Lambda power tools. They could do this. So it
happens automatically. Basically, if you're using
depends on the service. So some AWS APIs are passing the ID or not.
Context.
But this is the X-ray. Their specific name. It is not the span. Like in the this is actually exactly the same as in the distributed tracing. The ID is the same idea. The context. You're right. It was the span, right, in the specification before.
No,
and of course,
it's called context propagation for the trace ID, basically. So, well, it's just sending that information on, and then it becomes a part of the next trace. So basically, you see one. You see that everything is one trace.
Yeah, and for that, if you have a session, even better, right? You could say, okay, this is my system test. I'm just, sending something to S3. And I would like that the assertions that two Lambdas were actually executed. This would be already good enough, right? And this would be actually the first step, towards serverless Java. By the way, all my projects are serverless right now. And why? Because, suddenly for 2 years, everyone cares about costs and budgets. And this is, it was pointless 3 years ago, but now it's a different story.
I think what you mentioned is actually bringing out two thoughts in my mind, and both are excellent ideas. One thing that it just reminded me when you talked about the Lambda execution is I had a conversation, as I mentioned, like all of my stories lately are ideas of other people, which is great. So I was talking to this guy, really sharp architect, senior developer at a big e-commerce company, one of the biggest. And he was mentioning something about, I was asking him, okay, so we have all of this data, what would you do with it? And he said, well, I'm working on this project where we're running a lot of batch jobs, which is kind of similar to a Lambda execution, kind of like background executions in his case. And one of the things I noticed is that in our large company, enterprise rather, sometimes we trigger these jobs and we need to decide on the level of parallelism that we want to apply. And of course, this has cost ramifications as well. And he asked me, do you know what is the level of concurrency or parallelism that we apply to a batch job? And I asked him, well, obviously it depends on what you're doing and so on. Well, he said, no, it's always 100. And I asked him, okay, that's interesting, but why 100? And he said, well, I just found out that in the code, somebody created this constant called default concurrency, and the value was 100, and everybody just used that. So I asked him, okay, why don't they choose a different one that matches the job, like that kind of tries to optimize the marginal yield that you get from each additional level of concurrency? Some jobs can't be parallelized that much. Sometimes there's a critical section and it doesn't help you that you parallelize it more. and basically said, well, that would require research, and we can't research each and every single one. So we said, okay, let's look at this problem together, but with Digma as a data science tool that will just look at the concurrency and say, okay, this is the golden mean if you want to maximize throughput, and this is if you want to maximize latency, and so on. And that turned out to be a great application of, again, data that was just sitting there that ultimately can reduce cost because you're not wasting a lot of resources, and can also give you kind of a way to make a balanced decision. So I was just thinking about the story because I think that there is definitely a lot of potential in measuring these things and understanding kind of what is the implication in terms of cost. And then the other thing that this, yeah, go ahead. Sorry.
Similar story. Are you aware of AWS Lambda Power Tuning project?
No, I'm not.
So it is from Alex Casalboni. So I give you the link in the chat. And what it is, so basically, if you are running Lambdas in the cloud, you cannot buy CPU directly. You can only buy CPU indirectly, and you paying for gigabyte seconds. This is what happens. Wait a sec. Here's the chat. So, and what means is, if you're running Java, you can decide to run, Quarkus on 128 megs of RAM. Is fine. But what you will get is 1/10 of a CPU. And on 1/10 of a CPU, Java runs terribly slow. So I saw a project which started in 10 minutes because they wanted to save money, and they will not save money because Java runs unproportionally slow on 128 megs, so they are losing money and are slow. So per try and error is this known knowledge. So if you run Java on one CPU, it runs the best, I would say, from cost perspective. So you can run the Lambda with 1.8 gigs of RAM. So this is a lot of RAM, but you get one CPU, and you pay significantly less than with 128 megs of RAM, which is terrible. Now with the Digma, this could be a pure Java project where you can run some experiments, just deploying the Lambdas with different settings, and you get the answer. It was also interesting with money saving machine, right?
You're right. And I think right sizing is true not just for AWS, it's also true for Kubernetes nodes and other kind of areas.
But the difference is in Kubernetes is less obvious. Because and in Lambda you see per request what you're paying, right? So the effect is immediate because the entire invoice looks different in the Kubernetes. Because Kubernetes, you provision something, it runs all the time, and no one knows what happens inside. And they buy additional tools to get more insight, but it's basically a black box. But in Lambda is the difference. So you are paying per invocation, and the invocation
very, very costly for each inefficiency. It costs you a lot basically because each time it runs, you're paying. Yeah.
But from cost perspective, 2 transactions per second the entire month with 1.8 gigs of RAM will cost you $15. So if you think about that, this is, on Kubernetes, you will, for control plane, you are paying $100 or $80 just to have the control plane without, the worker node. So I would say, but if you have a lots of traffic, you can save a lot, right? This is the thing.
Interesting. And I think kind of another application of that same thing, but more from an optimization point of view, because as you said, when you're running things in serverless, for example, but also elsewhere, waste is costly. And on the other end, and this is a story that we went through in our own services where we were doing a lot of optimizations and reducing the footprint, but also working to make sure that we're as efficient as possible. So we were using Digma internally to find out like where the issues are. And initially we said, okay, let's take like the slowest areas and try to fix like the 10 slowest areas in the system each week. So we did that. And what we saw is that it didn't move the needle. So we came back and said, okay, this is very interesting that it happened. How come it didn't move the needle? Like, what's going on here? And then we started trying to see more about what are the things that we optimize versus what are the things that we should have optimized. And then we thought, okay, there is another factor to it, which is usage. So if something you've just optimized affects a minimal amount of flows, maybe it has some effect on a very slow process that it's slower, but in proportionally it's not that slow. Or if it's used once in a blue moon,
or batch, right?
Schedule, or batch, versus something that has a lot of effect all the time, then it makes a lot of difference. So we said, okay, let's, instead of measuring just slowness, let's try to understand the performance impact. So kind of try to simulate, if we made this better, what would the impact throughout all of the flows that are using this be? And this had amazing effect, because now we got a list also sorted that was more like, these are the key areas you should be focusing on if you want to improve the performance of your system, which we were doing at the time. So and then we went through that same iteration, but now each time we pick these 10 locations, it has a drastic impact on the system. So eventually we got to our goals, but much faster than we would have done otherwise. And this is kind of, again, another potential of, okay, the data is there, observability is there, it has a story to tell. All that stands between us and making it useful is some data science, statistics, and calculations. Okay, let's automate that. That's not a problem at all. Anybody can automate that. But if we can get a result that's useful, then that's a game changer in terms of productivity for the.
But in my case, it is useful per definition, because it is triggered by a system test, right? And if you know that a system test is essential one, like order process, and another, this even reverse, right? Because if you're ordering something, there's the margin cost. You can say, okay, if I call the API and it costs me €1, but I earn €5, no one cares about the €1. But if I'm calling or dollar, sorry, the euro is something in Europe. You are aware of it because of France, right? So your trip, but expensive dollar. Is it actually for you expensive euro right now? What is the relation between euro and dollar?
I think they're pretty close.
Okay.
Euro and dollar. But
so was Europe expensive for you, or is it cheaper than US if you compare the prices?
It depends on what. I think in general, like restaurants were reasonably priced compared to at least where I live, so it was not that expensive. Other things like, again, I was in Paris. It's a very central touristy city, so obviously some things like hotels were more expensive.
Okay, so hotels are more expensive, restaurants are less expensive. Yeah. Okay, interesting. And so if I call the essential use cases, then it is less interesting maybe. But because it really depends. So in one project we have essential use cases, which happens a lot. There are several thousand transactions per second. So this is important. And the others, typical use cases are not called that frequently, but it because you are calling your own API, then we can decide this is now a frequent use case and this is less frequent use case, because developers have a feeling, this is obvious that, on Amazon, you are looking at the products more often than you're ordering them, right? So this is the viewing the products or researching and searching for products could be more expensive than the ordering process. right? So this is yeah.
Mhm. Yeah, I think in general, it's kind of like we're highlighting several different aspects that are all extremely critical. So we started by mentioning cost, then we talked about efficiency and optimization and prioritizing technical debt. Like, you know, nobody thought prioritizing technical debt could come from tests, but it can because you can produce the right data. And it also goes back to even simple things like even mapping out your code and how it's being used so that you can kind of have that wisdom inside the code. So, to me, like one of the most useless things in the world is a single trace because it's kind of like a moment in time, and of its own it's not extremely significant. Like it can show you things, it's important, but it's just one trace. The more interesting things, and I'm surprised that, and we're still trying to find better and better visualizations for it, is what happens when you take 10,000 traces, a million traces, and superimpose them one on top of the other, and then kind of try to distinguish what are the main kind of flows and how are being if we have this meta tree right now of all of the different trees of all of the traces, and we look at a specific node in that tree, we can say, okay, so who's reaching out to it, and how does the, like whenever I run tests, we are essentially,
So you're
or
searching
even,
for outliers, right?
yeah, and we're essentially creating a live ever updating map of what the code looks like in runtime in terms of the different nodes and how they're connected. So I can look at any piece of code or any span in general and just say, okay, where in this noisy orchestra that is my microservices ecosystem does this fit in? And not just as you would have in the IDE, who's the direct calls for this, which is useful, but kind of time consuming to track for each time, but have this instant view of, okay, what does this participate in? And tests are a great way of trying to help create this map of the code, which is why we've also invested in kind of making code and trace interchangeable. So you can go from trace and click to see the code where you're at right now, or you can go from the code and see the traces that are related to it in terms, again, of the different flows. And this is where it gets interesting. And also a lot of the phenomena that we observe.
Could you link? Because in my case, it will be in test environment to Quarkus, two JVMs. Could you link, my system tests to the trace from the Quarkus JVM, right? So there will be a link.
Yes. So basically, as you run your Quarkus test, all of the data will get kind of tagged with that test name, and then and now we know exactly the test and the result, by the way, at the end, which is another information that we add to the trace. But then each node that it visits, like your endpoint, different methods, each of these in the trace now gets linked, so that if I look at the trace, I can look at that specific function and say, okay, get me to the code, or go to the code and say, okay, what are the flows that are using this piece of code? And this is, I think, something that we kind of developed as an afterthought. Like, it was kind of obvious that, of course, like if we have the data, why wouldn't we link it? But it's also one of these situations where
Is it available right now? Is it available right now? You could use it with Digma. Okay, and how I would use annotation on my system test, or how to tell Digma that I would like to link it, or what is the process?
So Digma has an on-off switch for observability, which is the main button in the plugin. And if you turn it on, then if you're using, I think currently we only support the JUnit variant, but if you're using any JUnit, it will automatically kind of instrument the test and basically provide that context. However, now that I'm thinking about it, right now for Quarkus, this will not work for you because we currently added it to the hotel agent, and Quarkus doesn't play well with the hotel agent. You should use the Quarkus extension. But I'm also working on a JUnit extension that does the same thing. So then it will work. So once I publish that out to Maven Central, then you can just pick that up and add that, and that will do the same effect. It's basically an interceptor for your test that injects all of the context in terms of what is the test name and code location, what is the after the test is done, whether it succeeded or failed, or what was the exception, and all of that. And then it will work as well. So,
but you have two instances of Digma, and one is on the server side in Quarkus, and the other one in my system test, right?
You can have one instance if you want.
No, two, because you have two JVMs. So I have one instance and two agents.
Yeah. So just to explain about the architecture. So Digma is essentially an OTel collector, which is just accepting OTel information. And then there's another, just a container that processes all of that data. And you can have, by default, it just installs locally on your machine. And when you install Digma, and then you can just, as you run your test, it will just give the feedback back to the plugin. You'll see the information. If you want to use multiple environments, not just on your machine, let's say you want to run CI tests, or you want to run some staging, performance tests, I don't know, anything else, then it doesn't make sense that those tests will send information to your laptop, because, it doesn't make sense. So then you can just deploy Digma as a Helm file to any cluster, or just deploy it as a Docker anywhere, and basically have the observability data send the information to it, just like you would send to Logs.io or CoreLogix or any APM. And on the other end, you have a backend endpoint that you just set your plugin to connect to, so that you can have multiple plugins connected to that same centralized Digma, where you can access the results about your code.
Exactly. This is what I thought. What I meant, that we have two JVMs and they have to be synced. Maybe it's no, it will be the same. So unit is just a client. It is actually makes no difference for you, right? Because the unit test is similar story, like two microservices talk to each other. So I was actually wrong, because my system test is like a microservice client, so nothing special for you. So the only thing is you have to instrument the JUnit to know when it gets executed, because usually it comes from outside. The API call comes from outside, flows to the other service, and in the JUnit case, it's just triggered by the JUnit. This is the only difference.
Yeah, and of course we had to, as usual, work around a lot of things just to make it very usable, because
so what are the features between our last conversations and now? So what happened with we talk about that you have millions of users already, but you know what?
Not millions, but one day we'll get there. There are several threads that are happening at the same time. On the one hand, there is the kind of what are the interesting things that we can learn about the code. This is like a whole thread, and there are lots of new ideas that come in regularly from the community, and lots of implementations that are done. So like every month we have like 3 or 4 new insights about the code that didn't exist before, and then we kind of test them out, check that they're viable, check that they're not creating false data, false positives, and then as they roll out more and more, we can see how people are using them and whether they give them values, which is great. So that's one track. On the other track, we sort of did a complete rehaul of our UI, because it seemed that giving an engineer like me and a couple of other geeks letting us design UI wasn't the best idea. I mean, it worked in the beginning, but it wasn't that usable as things became more complex. So we did like a lot of work on, okay, how do you get from here to there? What's the best way? What is the most important information you want to see? How do we prioritize the information so that we don't bombard you with just a lot of data? And that was done and is actually releasing this week, which is something I'm really excited about. Then we had a whole thing about measuring the impact, measuring the a performance cost, if I can put it that like that, which could, as you said, with lambdas easily translate to actual cost. And that was another thing that we worked on and released, a lot of concurrency optimizations and scaling issue analysis, and all of that was another track. And then testing is what I actually wanted set the trigger for this call, which is where we started hooking into the tests themselves and seeing if we can get the information from the test, use that in the UI to, again, create that mapping between the code and the test runtime information, as well as for other areas that are not in the code, like queries and things like that, and kind of use that as well to get more data. And the end result of all of these things was that we kind of see how it makes an impact and see how users can get to a stage where, and this is from their own stories, kind of detect things that they would otherwise may have detected at some point in production, or at the same time just work with shorter feedback loops, which really accelerates, because even if you could have caught it in a code review, the productivity loss of going back after a code review and changing things and fixing it and going back is something that adds up, versus just getting feedback, fixing, and so on. So
another question off topic. Are you looking at LLMs? Are you working with them right now, or is it
That's a great topic, I think. And first of all, talking about tests and LLMs, I would just caution people because I've seen a lot of folks use LLMs to generate tests. And I think that's a great practice, but all of the fallacies that we talked about in the beginning about the structure of the test and how they all come out in these projects.
Yeah.
Like, I think that just be careful that, that the fact that LLM generated 200 tests for you doesn't mean that they're valuable. So just look at the architecture.
I would say in general, right? I tested lots of LLMs and IDE integrations, and I would say it is great if you know what you are doing. They are helpful for trivial code. If you but they are, I would say, in 40% of all time wrong, completely wrong what they generate. Even 30, I would say 50 maybe. So you have to reject lots of suggestions. And then some are nice, and if you are fast, you are a lot faster. So this is my impression right now, and I don't think it can get better, because the LLMs learn, from stuff was in the internet. And if you look at Stack Overflow and whatever, this is not a lot of great stuff. This is lots of stuff is outdated, old patterns, and but still helpful. So, but I thought what you could do. You could, you have all your 10,000 traces, and ask the LLMs whether there are some patterns, pattern recognition, something like this. And if you get a hint, then you can actually follow the hint and do something with the data. So I would say hallucinations would be not a problem in your projects, because you have the actual data. So, and if your LLM says, I recognize here anomaly, and points back to your data store, then it's fine, because maybe it is a false positive, but at least to what it is linked, right?
Yeah, definitely. And I think that we've obviously experimented a bit with that use case, and we didn't always like the results, but we definitely will continue to test that out. I also kind of share the same impression that you have about LLMs, kind of from personal use with coding. They're great at specific tasks. Some of them can be like, I don't know. I constantly use them to generate regexes, because I always kind of like to. I always hated creating regexes. But other than that, they are prone to a lot of problems that create, I think, a risk. And
yes,
I sometimes just use them like as to break my writer's block if I don't know how to approach a certain thing, and then I get all like wild out up about, oh, this is terrible code, I can do it better, and then it just inspires me to write it better. But from our perspective, another challenge that LLMs pose is, okay, let's say I want to use this code that the LLM generated for me. What can I learn about it to make sure that it works? Because if it's code that I wrote, then I know a lot about it. But if it's completely generated code, and you'd be surprised like how much generated code there is in repositories today. Like,
after 1 year of LLMs, this is crazy that is so fast. I would say I cannot imagine if you build something more complex and you just use LLMs and you don't know really what you are doing, right? I mean, after 2 days is over. The code becomes so complex, there is no structure. So I think it is absolutely unusable after a while, and no one will understand this. So what you could do, you could, hire a real programmer, put the entire code base, summarize it with ChatGPT or whatever, and then try to refactor it. Because I think the code generation is for very trivial applications for CRUD. This is always the case. We could always have great generators for create, read, update, delete, but the challenge is always to understand the customer, the client, and then write efficient code, right, which is maintainable over years. This is the challenge. Otherwise, if you think about this, forget about source code. If they are so confident, they should generate bytecode. If the source code is not readable, I don't care about the source code. So the ChatGPT should generate bytecode, and then I trust, then I trust and then run it and forget it, because who cares about tons of code who no one understands, right?
Yeah, and I like it will get better. It will probably get better in terms of the let's say consolidating the coding conventions and styling, and kind of creating a context, so you don't need to kind of keep creating different prompts, but you kind of, it knows about this project and it knows which libraries you're using, and it knows how to, I don't know, generate the syntax for common things where you don't want to look it up. But I think we're still very far away from it being in any way close to replacing an engineer. I think we're very far away from that, and I think we're all kind of maybe became a little, or some of us became very optimistic because things went from like 10% kind of effectiveness to I don't know 30% really fast, but the remaining gap will be much slower to close. Like the problems that remain for AI to be truly effective are the harder ones. So I'm not sure it will get better at all of these things. But I think there is an opportunity here to feed the LLM, as you said, more data. So when I tell it to generate code or to correct code or to find a problem, let's feed it some of the runtime data and see if it can kind of suggest a solution or find out an alternative way, and so on.
You could. What you could do, because you have all the data stores, which code is efficient and which not. So you can actually create something more specific with your knowledge. You can say, okay, create code under these constraints, and you have the constraints. So if you create the embeddings for your backend data, then you could create a crazy efficient code, or at least reject it and say do it again, and until it happens, right?
Exactly. But then also efficiency is something that's relative, so it needs to be kind of in relation to how it's being used, and what are is it like single threaded efficiency? Is it do you want it to run at scale? Like how is that piece of code supposed to be used that it needs to be super efficient? And as you know, everything can have a cost in this case, so it's a trade-off.
Perfect. Where people can find you on the internet?
So I'm on Twitter. My Twitter handle is Doppelware. Can put it here and I'll also send it afterward.
We have it already because you were already on AHAC. So
awesome. You can just go to digma.ai and send us a message. There's also a Slack channel. So if you install the plugin, the first thing, or one of the first things you see, is an invite to join the Slack channel, where lots of us are talking and collaborating and thinking up new schemes about how to make everybody's life better. So if you want to be a part of the continuous feedback conversation.
How many Slackers do you already have there?
Oh, we have hundreds. I stopped counting, but it's really it's a really fun community, and I have to say, like, one of the things that really stand out to me is that, you know, many of the folks that I met, like, are really, you know, such innovators, and really do want to work and create new things. And I think it's very far away from maybe the stigma that some people might have of Java developers as being kind of more old timers and rusty, and definitely not the case. It's such a vibrant community. And
I never heard that, actually. So
I was a part of the old and rusty community, but it was in the J2EE developer development days, and we were always kind of very abstraction heavy, and talking about philosophical stateful beings and things like that. That it was kind of like a heavyweight conversation to have. And then Java, over the years, I think, was the advent of other languages, some of which since went back to kind of anonymity, but definitely Ruby at the time was kind of challenging Java to be, you know, we're the cool new guys. And but I think, and I think I mentioned that in our last conversations as well, that when I revisited the Java community after having, you know, been working on other languages for a while, I was absolutely surprised kind of by how different things are, how modernized like the latest iterations are, and how kind of focused on innovations the community is. And
Perfect.
I think that it's just it's kind of an open invite what I want to send out. So if you also want to participate and help, please, we're trying to get as much development insight into this. So definitely, if you're a developer and you've been thinking about these things, then definitely we want to hear from you.
Perfect. If you like, you can also join the AirHacks Discord and announce, you know, and invite members. So we have several hundred members as well. So if you're interested, join the AirHacks Discord and just say, okay, whatever, invite people.
Yeah,
and
maybe I'm there, so I'll just send a message.
Yeah, sure.
Perfect.
So thank you a lot, and see you in a year or whenever it's something interesting. We should rethink, you know, always great ideas, and talk again. And by the way, you were mentioned several times, or someone asked me about you. So it is actually, interesting stuff.
Perfect.
Thank you.
Thanks for having me on the show. Bye for now.